Hello everyone, today's video is on pyramids and cones. Just like the last one on prisms and cylinders, we're going to cover both surface area and volume sections 14.3 and 14.5. So let's get started. So first of all, let's talk about what a pyramid is. Here's its definition. A polyhedron, which is a word we've discussed in the past. It's a three-dimensional figure with flat sides, in which it only has one face that can be any polygon. That's called our base. And then the other faces, called the lateral faces, are triangles that all meet at a common vertex right up on the top. So pyramids are named by the shape of their base. So if you look at the example that I've seen here, we have a base that's a hexagon. All the lateral faces are triangles and meet up at the point at the very top. So this is a hexagonal, pronounced either way, pyramid. The next image you see here is a square pyramid because the base is a square. So let's talk about what a regular pyramid is. A regular pyramid is a pyramid whose base is regular. So in this case, a square is always going to be regular. All the angles are the same, all the sides are the same. But it could be maybe a pentagonal pyramid that has a pentagon as a base, but it's a regular pentagon. So we've pretty much discussed what the word regular means. It's the same case, but this time referring to just the base. So here's a couple other words that you'll need to know when it comes to pyramid. First of all is the altitude or height. We talked about altitudes with prisms, but it's the same thing here. From the vertex at the top to the base at the bottom, it'll make a perpendicular line. And that is the altitude. But the length of that altitude we call the height. And we can abbreviate it with just an H. Now there's height, which like if you go to the doctor's office, you have to stand up straight. But there's also something else called slant height, which will be abbreviated with an L. So the slant height is the height of one of the lateral faces, which we know are triangles, of a pyramid. So if you just looked at one side and actually went along the side, don't go straight down, but if you went along the side of the pyramid, then that would be your slant height. So in this class, notice the note with the asterisk at the bottom. Assume that pyramids are regular unless stated otherwise. So the formulas that we work with are only for regular pyramids, but don't worry because you'll be assigned nothing but regular pyramids in this class. We also have to talk about cones. So cones, like a pyramid, has one base and one vertex that's not on that base. But unlike a pyramid, the base is a circle, not a polygon. So looks kind of like a pyramid, but if you notice, the base is a circle, so instead we call it a cone. It has some of the same terminology, base. It has an altitude or height, H. A slant height as you go along the side of the cone, L, the vertex at the very top, and since our base is a circle, I included where the radius would be located, although it could be any line from the center to the edge of that circle. So assume cones are right cones, meaning that the altitude is perpendicular to the base. There is a such thing as a cone that's not right, but we're not going to be using those in this class. It's kind of similar to in the video with cylinders. You had right cylinders and oblique cylinders that can kind of be tilting in one direction. It would be the same thing with the cones. If it's standing straight up, it's a right cone. If it's tilting to one side, it's not a right cone. But again, you will not have those in this class. So now let's talk about surface area. So these formulas are both for pyramids and for cones, which is why they were grouped together. So lateral area, we've already discussed what that is. That's the surface area of just the sides. That is LA equals 1/2 P times L. Like before, that P stands for perimeter of the base, which would be the same thing as circumference if you're talking about a cone, because the perimeter, which is circumference for a circle. And L is that slant height that we talked about of whether it's a pyramid or a cone. So it's pretty simple, actually. It's just a matter of knowing what your perimeter is and your slant height. To find the total surface area, similar to what we did with prisms and cylinders, you have to take that lateral area and add one base, the area of that one base, which will mean that you'll have to refer to the area formula for whatever that shape is. Notice though that we only add one B and not two B's. That's because pyramids and cones only have one base, while prisms and cylinders have two bases. So here's our first example problem. What's the lateral and total surface area of the hexagonal pyramid? And it shows us the values as seen. So we'll need our formula, LA equals 1/2 P times L. P is perimeter. They gave me that one side of that base was 6 inches, and I know that this is a regular pyramid, because I said assume all pyramids are regular, meaning all sides of that base are exactly the same. So 6 inches times 6 of those same sides will leave us with a perimeter of 36 inches. They straight out gave us a slant height, which was 9 inches. So now it's just a matter of putting all of that into the formula. When we do so, you take your 36 inches, put it in for perimeter, 9 inches for slant height, multiply all of that together, and you should end up with 162 square inches. Now we're ready to look at surface area, total surface area. I know that that's going to be LA plus B. My base is a regular hexagon, so I have to think, well, what's the formula for the area of this regular hexagon? And the formula for all regular polygons is A equals 1/2 little a, which stands for apothem, times perimeter. So again, this information was given to us. The apothem was 3 square root 3. And my perimeter I already found was 36 inches. So when I multiply all of that together, I end up with 54 square root of 3 inches squared. Putting all of that together, I add that 162 of my lateral area plus my 54 square root 3 of my base. And I put that all in the calculator together. The problem wasn't very specific as to whether or not I should round, so I just kind of put in everything I saw. If you were doing this assignment in class, it would tell you to either leave it in exact form, which would be the first part of this, that's exact, or approximated or rounded, which is what it is at the bottom, which ends up being approximately 255.5 square inches. Here's another example problem. Find the lateral and total surface area of the cone below, and that should be area. Anyway, so moving on. I know I need to find my lateral area first. So I wrote down my formula for lateral area, 1/2 P times L. Remember that perimeter for the base being a circle would just be circumference. So that's C equals 2 pi R. And I know that that R radius is 40 millimeters because that was given to me. Now that L for slant height, that was not given to me, but if you notice, I was able to make a right triangle using one radius. I know that that radius is 40 because it's half of 80. My height was given to us, but that's regular height, 45 millimeters. I don't want regular height of the altitude. I want slant height along the side of the cone. So what I can do is I could use this right triangle and use the Pythagorean theorem to solve for slant height. So when we do that work, I put in 40 and 45 as my A and B, because C, or L in this case, is always the hypotenuse and it goes at the end. You should end up with a slant height of the square root of 3,625. I wish I could take that square root, but it actually is not a very nice number. So for now, I'm going to leave it like that. After plugging everything I know into my formula, 1/2, I put in 2 pi R, and then slant height, square root of 3625. Notice that the 1/2 and the 2 will cancel. So that's the reason I actually didn't work out what the circumference was yet. I could have if I wanted to, but I knew that they would cancel, so I just left it like that. So really what I have here is the 40 pi times that 3625, which when I do that, is approximately 7,566 millimeters squared. So that is my entire lateral area. I still have to find my total surface area, and I know that that's LA plus B. So for this problem, I just really have to find the area of the base. So since this is a circle, area is pi r squared, where that r is 40. That leaves me with 1600 pi. So I took my previous answer, 7566, added 1600 pi, and when you put that in the calculator, it's approximately 12,592.5 millimeters squared. Now that we've talked about surface area, let's talk about volume. Volume of pyramids and cones is the same as you might imagine. It's 1/3 the area of the base, which is a capital B, times the height. So first of all, a reminder that capital B means area of the base. So you'll have to refer to the area formula for that specific shape. And this time it's H, not L. So we're actually talking about the height of the altitude, not the slant height. Let's practice. So for our third example, it asks, what's the volume of a square pyramid with base edges of 40 feet and a slant height of 25 feet? So again, I know I'm going to have to start with my volume. Right away, I notice that they gave me a slant height and not a regular height. So I'm going to have to do some work here. First of all, I need to know the area of the base. I know that that base is a square. And to find the area of a square, it's S, which stands for side length squared. Same thing as length times width, but since it's the same dimension, it's the same number. I know that one side is 40. So 40 squared is going to leave me with the area of the base of 1600 square feet. Next, I want you to notice this triangle that we were able to come up with. So they gave me my slant height. And similar to what I did last time with the cone, I'm going to make a right triangle here. One of the sides is my regular height, my altitude. The bottom is going to be half the base, not the whole length of the base. And then, of course, L for slant height. I know that the slant height is 25. Half of 40 is 20. But what I really need to know is what H is, the height. So again, because we're working with a right triangle, I could use Pythagorean theorem. This time, H I put in the left side because it's not the hypotenuse. H squared plus 20 squared equals 25 squared. And then as you work that out, and you can check your work with the work I have here, H, that height, ends up being 15 feet. So now that I know the area of the base and the height, I can plug it all into my formula for volume. So I have there shown at the bottom 1/3. My area of the base is 1600 square feet. And my height was 15 feet. So when I multiply all of that together, I get a total answer of 8,000. And since I had feet squared times another dimension of feet, my total units is feet cubed, or cubic feet, which makes sense since we are talking about volume. This last example is pretty straightforward. Determine the volume of the cone. So we're given here the cone that has a height of 12 and a diameter of 14 inches. So I write down my area for volume, 1/3 area of the base times height. Since this is a circle, the area of the base is pi r squared. And so now I'm just going to be plugging stuff in. My radius is going to be 7 inches since it's half of my diameter. And they gave me that the height was 12. So just multiplying all of that together, as is being done now. You work it all out and end up with the final answer of 196 pi inches cubed, which that in and of itself is the correct answer, especially if we're told to leave it in terms of pi. But if the problem had actually said round or given an estimated value, anything like that, when you multiply it with pi, you end up with 615.75 approximately cubic inches. So you will have to look at whether the problem wanted the solution to be left in terms of pi or rounded at the end. So those were all the examples that I had for you there, but a few things to discuss. So first of all, things to keep in mind. Composite figures, again, that means that several figures were put together. I didn't go over any in this example, but if you were to have some, a composite again, it would require you to determine the desired values of the individual shapes first and then add them together, as we always do with composite figures. Another note, number 2, make sure not, keyword not, to confuse or use height as slant height. So height will be an H, slant height will be an L, and they actually are two different ones. And the third note I want you to keep in mind, if a specific value is not given to you, use your knowledge on triangles, regular polygons, or circles to find that value on your own. So it's not that you can't do the problem. Every problem will give you enough information to work it out. So if the value is not given to you, you can probably figure it out by using things you know from the past. All right, I know that went kind of fast, but that's everything you need to know about pyramids and cones. Please feel free to rewatch the video, pause wherever necessary, so that way you can get all the information you need before class. We will be checking these notes and doing an assignment on this next time I see you. All right, bye.